So, everywhere we saw that the mirror has got mirror comes at an angle of half the angle of rotation. So, seems like a general result. So, can we prove this? So, let us try this to find out. So, a general combination of a rotation by an angle theta and a reflection in a mirror passing through the rotation axis. So, let us do it, let us do means in a sense we have proved it case by case taking all the this thing, but a general proof can be again given geometrically, but we will do it algebraically through not sites operation, but through matrix operation, because the translation is not involved. We use sites operator when we have the translations. So, let us use an orthonormal basis, because that is convenient to write the rotation matrix. So, rotation by an angle theta about an origin, we had done that if you remember. So, we start with the unit vector 1 0. So, and that will rotate by theta. So, its component so this is a rotated 1 0 vector and its components are cos theta and sin theta. So, the matrix first column is the rotated 1 0, whatever happens to on rotation you write it as the first column, and you are seeing that the vector it is going to is cos theta sin theta, and similarly R E 2 goes to minus sin theta cos theta. So, that is the rotation matrix. The reflection matrix mirror plane. Now, mirror plane you can take in any orientation, but it is convenient to choose it along your x axis or y axis, since x axis is a better reference line. So, let us call that as our mirror, and I am calling this a mirror at 0 degrees. So, mirror is being characterized by its tilt with respect to the x axis. So, this is M 0, and what will be its columns? First column 1 0, because that is where it takes E 1. E 1 is now along the mirror, so it does not go anywhere, it reflects into itself. The second vector will reflect downwards, will become 0 bar 1. So, all you have to do is now to combine these two operations. So, let us say we first apply r theta and then we reflect, that is how we were doing in the stereogram also. So, what is rotation by theta by combined with a mirror reflection which is inclined at 0 degree to the x axis. So, that is what we are trying to find. So, 1 0 0 bar 1 multiplied by cos theta, that is a simple matrix multiplication. Remember, we are combining a reflection type 2 with a rotation type 1. So, the resulting operation has to be type 2, and we know that type 2 operation in 2D is a mirror. So, it is a mirror, but which mirror? So, to see which mirror, we have to find the line of mirror, orientation of the mirror. So, how do we find orientation of the mirror line? So, let x y be the vector along the line. So, then what will this mirror do? Let us call, since we know that it is a mirror, so it will be some mirror passing through the origin. So, it will have some inclination. So, let us call this m alpha. So, orientation means what is that angle alpha. This is what we want to find out. So, if x y is a vector on the mirror line, then what will m alpha x y be? It will remain x y. So, essentially in terms of your matrix jargon, you can say that x y is an eigenvector with an eigenvalue 1 of this matrix m alpha. Okay. But that is not important, all what is important here to try to solve this equation. So, try to solve this equation. So, we write the matrix in full. This is our m alpha matrix multiplied by x y, and we want it to be equal to x y. Yeah.
M alpha should be identity matrix, can't we say that? Because
No.
M alpha.
Identity, yeah. See, if matrix was unknown and there was this equation that a matrix times a vector is the same vector, then one possible solution for the matrix was identity. Here matrix is known, these thetas, because I am combining it with some rotation, theta is known. So, now matrix is an identity is not a possibility which you are considering, although if matrix was an identity, the equation would have been satisfied, but I am my unknown is not the matrix, but the vector. Matrix is given, but what is the vector which will not be moved by this matrix, will not be disturbed by this matrix. It is a very calm vector. So, the matrix is trying to disturb it, but it is constant. So, we get these two equations if we multiply out the matrix. So, cos theta minus 1 x from 1, cos theta minus 1 x is equal to sin theta y, or y is equal to can you do some trigonometric simplification of this? Cos theta minus 1 is
It minus tan theta by 2.
minus tan theta by 2. So, cos theta can be written as 1 minus 2 sin square theta by 2, is not it? Minus 1, and sin theta can be written as 2 sin theta by 2 cos theta by 2. So, it is a line y is equal to mx, and m is the slope, and what is the slope? So, how is the line inclined? So, I had some sort of an n-fold rotation there whose throw angle was theta. So, there was a rotation of theta about this, and I had a mirror plane which was lying along the x axis, and now I am finding that the combination of this theta rotation and this mirror is actually another mirror which is at minus theta by 2, which is exactly what was happening in your stereographic projection way of looking at it also. The two operations are non commutative, that is what we calculated was m 0 r theta. So, m 0 r theta turned out to be m minus theta by 2. If instead you would have calculated the other way round, you can do that as a homework, then you will see that if you apply m first, so if you have r theta followed by m 0, you will again have a mirror at theta by 2, but this time plus theta by 2. So, means some of you will find this as more convincing than drawing these silly stereographic projections, but the two are in one to one correspondence. Means when you have developed enough geometrical intuition, the stereographic projection in a sense helps you in working out what the matrix will also give you, but tediously and through algebra, and as you can see some trigonometry, and one by one. Of course, we have found only one mirror at the moment. So, you will have to, and as you saw that there are many more mirrors. So, you will have to start combining other operations. 6 with mirror will give you another mirror. Again 3 plus is also there in the group. So, 3 plus with the same mirror will give you yet another mirror, and so on. So, we are now convinced and we have completed the list of 2D point groups. When we say 2D point groups, 2D crystallographic point groups, because this restriction from 1 to 6 with 5 not being present is because of the crystallographic requirement of periodicity. Otherwise, you can have 8 mm, 7 mm point group, pentagon symmetry is 5 mm, any polygon, n-gon polygon has a symmetry n mm. So, arbitrary objects can have all these point groups, but crystals cannot have. So, we call this 2D crystallographic point groups. So, there are 10 of them. So, 10 crystallographic point groups, and those we have now worked out as 1, 2, 3, 4 and 6, and m, mm2, 3m, 4mm, 6mm. These are the only possible symmetries. Only possible symmetries in 2-dimensional crystals which will leave a point fixed, and that is why the point, because all these were being represented by, let us say, matrix, and matrix will never take 0 0 vector anywhere. Whatever the matrix, 0 0 multiplied by it will only give you 0 0. So, all these operations leave the, whenever you are representing them by matrix, you mean that origin is the fixed point of that operation. Now, let us bring the translations. Yeah,
So if we keep two mirrors at an arbitrary angle, that will be not a symmetry.
it's a good question. Let us look at it. Okay, so we will take this up, but before let us consider Priyansita's question, that what will happen if we were combining a rotation axis with a mirror plane. What if we combine two mirror planes themselves at some arbitrary angle? If you take these nice angles which we are getting, then you will get back to these point groups. So, if you combine two mirror planes at 30°, you will get 6 mm, at 45° you will get 4 mm, 60° you will get 3 mm, 90° 2 mm. If you combine them with any other angle other than this, then the question is what should that angle be to give you a symmetry. So, if actually you can have, as I was telling, that you can have any n mm symmetry. For any arbitrary integer n, we have already in our proof we were not fixing theta. So, all in our proof, if we are considering n fold, which is outside this 1 to 6, then all we have to do is to set theta is equal to 2 pi by n. So, if we set theta is equal to 2 pi by n, I will get an n fold axis, and that will then tell you that mirrors are at half this angle, that is mirrors are at pi by n. Theta is 2 pi by n for rotation. So, for a consistent symmetry operation, you want to come back after n operations, you want to come back to your original position. Otherwise, if you take some arbitrary angle by which after n operations you do not get back to your original position, but let us say slightly instead of 360 you go to 361, that will happen if your angle was some arbitrary fraction or an irrational number, let us say. So, an irrational number, any integer multiple will not bring it back to an integer. So, one constraint for symmetry operation is that the angle theta has to be a submultiple of 2 pi. Okay. It has to be 360° divided by some integer. If it is 360° divided by some integer, then you are happy and you can combine mirrors. So, you can combine mirrors by so if you have two mirrors at theta, let us say you will have, let us say alpha, you are combining mirrors at alpha. So, alpha should be the angle between mirrors should be some submultiple of pi, and this combination by the reverse operation what we have seen will give you a point group with rotation theta two pi by n that is n fold, and is giving you mirror at half that angle. So, you will get a point group n mm. So, answer to your question is that you can select arbitrary angle, but not more arbitrary than pi by n if you want a symmetry, and depending on what n you select, you will always get a point group n mm if you set your mirrors at pi by n. But unless and until n is equal to 1, 2, 3, 4 and 6, those point groups will not be consistent with translation and cannot be used for crystallography or crystal symmetry. But I have 5 mm and I can have a nice pentagon which is having a 5-fold symmetry. But pentagon's rotation angle is pentagon's rotation angle is 360 by 5 is equal to 72 degree. So, the mirrors are at 36 degree. So, mirrors are at 36 degree. If you take theta is equal to 37 degree and combine your mirrors, you will get you will keep getting an inconsistent set of mirrors, means you will never come back to an original mirror. So, you will keep generating newer mirrors.